Understanding data types is the foundation of statistics. All data can be classified as either qualitative or quantitative. Qualitative data, also called categorical data, describes qualities or characteristics. It groups data into categories without numerical meaning. Examples include colors, brands, or survey ratings like happy or sad. For instance, colors like red or blue are qualitative, they name categories but have no numerical value. Similarly, car brands classify vehicles but don't measure anything numerically. Quantitative data consist of numerical measurements. These are numbers that represent counts or measurements. Examples include heights, temperatures, or test scores that can be mathematically analyzed. A person's height of 175 centimeters is quantitative, it's a measurable quantity. Similarly, body temperature of 98.6 degrees is numerical data we can calculate with. The key difference is that qualitative data categorizes while quantitative data measures. With qualitative data, we can only count frequencies. But quantitative data allows all mathematical operations like averages and standard deviations. Consider a customer survey. Star ratings are quantitative, we can calculate averages. But favorite product choices are qualitative, we can only count how many chose each option. Now that we understand quantitative data involves numbers, we need to distinguish between two important types: discrete and continuous data. Discrete data consist of distinct, separate values that you can count. These are often whole numbers with no possible values in between. For example, you can have 3 cars in a parking lot, but not 3.5 cars. A dice roll showing 3 is discrete, it can't be 3.2. Similarly, a family having 2 children is discrete, you can't have half a child. Continuous data can take any value within a range. These measurements can be infinitely divided into smaller parts. For example, your height isn't exactly 175 centimeters, it might be 175.328 centimeters if we measure precisely enough. Precise measurements like 175.3 centimeters show continuous data can have decimal values. Even time is continuous, between any two moments. There are infinite instants we could measure. The main difference is that discrete data is counted in whole units, while continuous data is measured with any precision. Discrete data has gaps between values, but continuous data flows without jumps. With better measurement tools, continuous data reveals more precision. At first we might measure 3.5 units. But with a finer scale we see it's actually 3.52 units. This refinement is only possible with continuous data. Discrete data is used for counting things like inventory or website visitors. Continuous data is essential for precise measurements in engineering and science. Financial markets use both. Share counts are discrete but prices move continuously. Money often confuses people. Coin counts are discrete, but stock prices move continuously with decimal precision. Context determines whether money data is discrete or continuous. When working with data, it's crucial to understand its measurement scale. There are 4 fundamental scales: nominal, ordinal, interval, and ratio. Each provides different information and allows different mathematical operations. Here's a quick overview. Nominal data has categories without order. Ordinal data adds ranking but no consistent intervals. Interval scales have equal steps but no true zero. Ratio scales have it all: order, equal intervals, and a meaningful 0 point. Nominal scales are the simplest. They just name categories without any order. You can count how many are in each category, but you can't say one is more than another. Gender, eye color, and car brands are classic examples where categories are distinct but not ordered. Gender categories like male, female, and other are nominal. None is inherently higher than another. Similarly, eye colors can be labeled but not meaningfully ordered from low to high. Ordinal scales add ordering to categories, but the intervals aren't consistent. We know PhD is higher than college, but not by how much. Survey ratings like poor to excellent show order, but the steps between aren't equal. A 1 to 5 rating scale shows order, but the difference between 2 and the third of may not equal 4 and 5. Education levels are ordered, but the effort between high school and college differs from college to PhD. Interval scales have numbers with equal steps, but no true zero. Temperature shows this well: 20 degrees Celsius isn't twice as hot as 10 degrees Celsius. And 0 degrees Celsius doesn't mean no temperature exists. But 20 minus 10 equals 10 degrees is meaningful. The equal intervals between temperature marks show consistent measurement. Calendar years also have equal intervals. The gap between 2020-2021 equals 2021-2022. Ratio scales have it all: order, equal intervals, and a true zero. 0 means complete absence, and 10 kilograms is truly twice 5 kilograms. This allows all mathematical operations including multiplication and division. Distance shows perfect ratio properties. 0 kilometers means no distance, and 10 kilometers is exactly twice 5 kilometers. Population counts also work this way. A town with 100,000 people has exactly double the population of one with 50,000. Let's compare all scales. Nominal data like eye color just names categories. Ordinal scales like education level add ranking. Interval scales like temperature allow subtraction. Ratio scales like weight support all operations including division to say twice as heavy. These scales form a hierarchy. Each level adds more mathematical capabilities. Ratio is the most powerful, containing all properties of the lower scales. A customer survey often uses all 4 scales. Gender is nominal. Satisfaction ratings are ordinal. Room temperature is interval. And purchase amount is ratio. Knowing these differences helps analyze each properly. I hope you found this video helpful. If you enjoyed it, please give it a thumbs up. Subscribe to the channel, leave a comment, and share it with your friends. Your support means a lot. See you in the next video.